All right, so we're starting with, it says find the remaining 5 trig functions of theta. So it gives you information. You have to draw the triangle and then solve the other trig functions. So 32 cosine of theta is equal to 1/5. And it tells us that theta is in quadrant 1. So we set it up. Quadrant 1's up here, so we draw our triangle. Same way we've drawn them before. Then using the values that were given to us here, we're going to put that stuff on the triangle and then solve for the other side. So cosine is adjacent over hypotenuse, so this value is going to be 1. This value is going to be 5. Then I need to solve for the other side using the Pythagorean theorem. So I'm going to do a is equal to the square root of 5 squared, which is 25, minus 1 squared, which is 1. So this is the square root of 24. And you can break it down if you want. I'm just going to leave it as the square root of 24. And then we're just solving the 6 trig functions. Obviously, cosine was already done for you, so we just copy it down. So sine of theta would be what? Square root of 24 over 5. And what about tangent?
Square root of 24 over 1.
Yep, square root of 24 over 1, or just square root of 24. So then cosecant would be what? Square root of 24 over 24. So remember, we can't have a radical in the bottom, so to multiply by square root of 24 over the square root of 24. Secant, 5. Lorelai's number. And then cotangent, yep, square root of 24 over 24. So it was, whoa, not that. So it would be 1 over the square root of 24, so you have to rationalize it. That's how we get there.
Is this like it? Or is there something else like for the chapter? Like for the section?
There's also the stuff where we're using the identities to rewrite stuff. I'm going to do one more of these just so we see it. 34 cosecant of theta is equal to negative 5 over 2. Theta is Theta is in quadrant 3. So we know that quadrant 3 is down here. So we know our triangle is going to be down here. Now, we're not used to necessarily working with cosecant just right off the bat. We normally find sine first and then we find cosecant. So you can either go ahead and just figure out where this stuff goes, or you can go ahead and make your table over here first and then plug stuff in. So that's probably the way I would recommend you do it, just to make sure you get things in the right spot, because obviously you don't want to start out from the beginning wrong. So cosecant is negative 5 over 2, meaning sine is what? Negative 2 over 5. So that means that this is opposite over hypotenuse, so this is 2 and 5, but we have to pay attention to this negative sign. So it's negative, meaning I need to find the one that's going in the negative direction, so this 2 is going to be negative. The hypotenuse can't be negative, so that one's pretty easy. When you have tangent, if it's negative, you have to see which direction's actually going negative. Or it could be positive and both of these values be negative because of where it falls. So to find the other side, Pythagorean theorem, so a is equal to the square root of 5 squared, so 25, minus 2 squared is 4. So this is going to be the square root of 21. So this value is the square root of 21, but notice, why this is so blurry. It is also going in the negative direction, so we need to put a negative sign on it. So then using that information, what is the cosine of theta?
Negative 21 over 5. Or the square
Yes.
root of 21.
Negative square root of 21 over 5. I was looking at, I was processing the tangent values when you said cosine, even though I definitely asked for cosine, so that's why I looked at you weird when you said, okay, anyways.
I also read the square root, so that's just what I thought you were looking
Oh, no, I was looking at the fact that I was thinking tangent, even though I requested cosine. So tangent would be what?
Negative 2.
So initially it would be negative 2 over negative square root of 21.
But then it would be negative 2 with the square root of 21 over 21.
Yeah, so the negatives are going to cancel. So it'll be 2 root 21 over 21. So then secant,
5.
yeah, don't forget the negative. 5 square root of 21 over 21. And cotangent, square root of 21 over 2. So that's why I like to usually write what the value is first. If I have one that has to be rationalized on the left, because then I just flip it when I get over here and I'm not having to do a whole bunch of other cancellations. Any questions about that type? So the other problems, like the ones that you would have in the homework, are a quadrant 2 and a quadrant 4 problem, so just make sure you analyze what the signs need to be on the stuff, because otherwise, from the beginning, your problem is wrong, which is awful. All right, so these next ones say to write each expression in terms of sine and cosine and then simplify the expression so no quotients appear and all functions are of theta only. So we each have to rewrite stuff, basically, and simplify. So we'll pick a few of them. So something like 54 to begin with. We have tangent of theta times cosine of theta. So it wants me to first rewrite everything in terms of sine and cosine. So what can be rewritten and how in this one so far?
What's it equal to?
It's not. We're simplifying. Tomorrow's verifying. Today we're simplifying. Rewrite everything in terms of sine and cosine, and then we're going to simplify it down.
It's sine over cosine.
So this is sine theta over cosine theta
Cosine.
times cosine theta.
So it's equal to sine.
So those cancel. So we're left with sine of theta.
As much as I enjoy these, I really don't want to do it.
58. Sine of theta times secant of theta. So I always first look at what can I rewrite
Rewrite secant.
as what?
1 over cosine.
Sine of theta times 1 over cosine of theta, which is going to reduce down to what?
Sine over cosine, which is tangent.
Yep. I'm okay with you skipping that step and just saying it's tangent. 60. Cotangent squared of theta times 1 plus tangent squared of theta. So anytime you see a squared, you should think what? What type of identity? No, squared.
Squared.
Specifically with this, not just like in general. What identities have squareds in them?
Oh, quadratic property.
No, trig ones.
Pythagorean.
The Pythagorean identities. So which one is 1 plus tangent squared? Or could be rewritten as 1 plus tangent squared?
Cosine squared. Right.
Secant squared.
Secant squared. So we have cotangent squared of theta times secant squared of theta. So then now I can rewrite these things. So the squared, this is just so you for reference, this is the same thing as this. So I can rewrite each thing as something squared over something squared. So cotangent in general is what in terms of sine and cosine?
Cosine over sine.
Cosine over sine. So this is going to be cosine squared theta over sine squared theta. So it still follows the principle. You just put the squared on it. And then secant is what?
1 over cosine.
1 over, so since it's squared, it'll be 1 over cosine squared. Cosine squareds cancel, leaving you with 1 over sine squared of theta, which is what?
Um,
1 over sine is?
I can't think of the name of it, but isn't it CSC?
Yeah, cosecant. So it'll be cosecant squared of theta. Let's see, something like 62. Secant of theta minus 1 times secant of theta plus 1. What does this look like? It's a special type of something.
have the name.
Or can you tell me what it factors into if you don't remember the name?
Secant squared minus 1.
Secant squared theta minus 1.
That's tangent squared.
Yep, so secant squared theta minus 1 would be tangent squared of theta, and you can just leave it like that. Okay, so that was just a manipulation of the Pythagorean identity. And it does to rewrite stuff in terms of sine and cosine and then simplify it. You don't need to do that. This one did not lend itself to that, so you don't need to do that. That's just kind of the recommendation because that's usually the easiest way to start solving them. But I would not have done that with this problem. Let's see, 66. 1 minus sine squared of minus theta over 1 plus cotangent squared of minus theta. So what does the minus theta inside the sine do? And then also inside of cotangent, what does it do? What happens to the negative? Well, just in general. The property that we had, they were like the negative something something properties, or even odd identities, I think is what they're called. What happened to the sine one?
It was negative.
It makes the whole thing negative?
Yeah.
All right, so we're going to throw this negative out front. So this is going to become 1 plus sine squared of theta over
Minus cotangent.
They may want us to do something else first instead of doing it in that order. Hold on. We need to do this in the opposite order for things to work out. So sometimes you'll do something and then you're like, well, there's nothing else that I can do with that. If we left them and then took the negatives out at the end, it'll actually work out better. So I'm just going to cross that out. Oh. because sometimes things don't work, and that's okay. So we try something different. So 1 minus sine squared is what?
Cosine squared.
Cosine squared. So I'm going to rewrite that as cosine squared of minus theta over, what is 1 plus cotangent squared? Cosecant squared of minus theta. And then now I'll use the negative stuff. So of cosine, what happens to the negative?
Negative cosecant squared.
So cosine, wait, did I say cosecant or did I say cosine?
I think you said cosine.
So cosine of negative theta, the negative just goes away because it's even. So this is just going to become cosine squared of theta over
Cosecant. The negative stays.
So we put the negative. My goodness, it's not working. So then,
It'd be cosine squared over and then 1 over sine squared.
yeah, which then, well, I would probably just leave it here. I'd probably just stop here. It's not really going to get you any more simplified by doing anything else. So I would say just leave it. All right, let's look at 74. 74, we have secant squared of theta minus 1 over cosecant squared theta minus 1. So secant squared theta minus 1 is
Tangent squared.
tangent squared theta over cosecant squared theta minus 1. Cotangent squared theta.
Equals 1.
So this is going to be sine squared theta over cosine squared theta all over cosine squared theta over sine squared theta. When we divide by a fraction, we multiply that by the reciprocal or keep change flip. So this is sine squared theta over cosine squared theta times sine squared theta over cosine squared theta. Which is what? Not 1.
Oh, wait, no, it's not.
So this becomes sine to the 4th of theta over cosine to the 4th of theta. All right, I think that's sufficient. Y'all need to see any more? Are we okay?
I'm good.
All right, then your problems are 31, 33, let's see, 53, 55, 61. Now 61 is going to be similar to 62 that we did, but you're going to need to rewrite one of them first in order for it to make sense, probably. And then 73. And if you feel like you need more practice after that, I would just pick a few more and do them.